What's up? I'm Vin, and today I want to go through parts 2, 3, and 4 of the June 2021 Algebra 1 Regents. So let's get started. Question 25, we're solving algebraically for y, which means we have to show all of our work. We can't just use the calculator. So here, we could distribute 4 on both sides, or notice both sides have a matching 4, so we could divide both sides by positive 4, and then that's going to wipe out the 4 on both sides like this. So now what we have is y minus 3 is less than or equal to, and we have 2y plus 1 here like this. So now what we could do is we could subtract 2y on both sides. And this is just a matter of preference. Some people might prefer to subtract y to the other side. But I like to move everything to the left, variables to the left and constants to the right. So now we have y minus 2y is minus y. And then we have minus 3 is less than or equal to 2y minus 2y will cancel. And we'll be left with 1 here. So now we just add 3 to both sides. And that brings us to this step. So we have minus y and then negative 3 plus 3 cancels is less than or equal to 4. So now we want to solve algebraically for y, not negative y. So what we're going to do is we're going to divide both sides by negative 1. And just know this is a real big idea. Anytime you divide or multiply both sides of an inequality by a negative, the inequality sign flips. So that's going to give us y, but then instead of less than or equal to, it's going to flip to greater than or equal to, and then 4 divided by negative 1 is negative 4. And here's our answer to question 25. For question 26, we want to graph this function f of x over the interval from negative 8 to 0. So if we hop over to the calculator view, if we want to graph absolute value, you press math, you go to the right under number here, and then ABS, the first one, is absolute value. And then we had 1/2 x plus 3. For 1/2, I could just put 0.5. So I have 0.5x plus 3, and then we're just going to press zoom 6 here just to make sure the calculator's in standard mode. But notice they told us to graph this on the interval from negative 8 to 0. So what I could do is I could change the x minimum to negative 8, and I could change the x maximum to 0. That way I know exactly what our picture should look like. So when we actually graph it, it should look something like this. And notice there's all this extra space here. So one thing I could do is I could also make the graph shorter. So I could make this, let's say, go from negative 5 to 5. And this will give us a much clearer picture of what our graph should actually look like if we just focus in on the parts that actually contain the graph. Now, one other thing we could do is we could go to the table here, and this calculator, I'm going to switch the window back into auto mode here. So if we switch back over to auto, this is going to tell us, once again, the significant values that we need. So if we focus on x equals negative 8 to x equals 0, this will give us everything we need. Now, this is only a 2-point question, so we don't have to show a ton of work here. But what I would do is I would maybe just copy down a few significant points from the table. I would copy down the ones with whole numbers, so all the even numbers here. If we have negative 8, we have negative 6, negative 4, negative 2, and then 0, because those give us whole numbers for the y coordinates, whereas the odd numbers give us the decimal values here. So if we count this out now, we have negative 8, 1. So we're going to the left 1, 2, 3, 4, 5, 6, 7, 8, and we're going up 1. So this is 1 point that we're plotting. So we're going from negative 8 and we're stopping at 0. Now negative 6, 0 is the next point on this graph. And then we have negative 4, 1 would put us over here. And then negative 2, 2 would send us up here. And then 0, 3 would put us here. So we could notice now when we connect this that it matches the picture that the calculator gave us here, that we have kind of this V-like shape here, except the right side is going to go higher than the left because of the interval they gave us. But this should be sufficient here. If you really want to play this safe, what you could do is you could label some of these. So this is negative 8, negative 6, negative 4, negative 2, and 0. And then you could call this, just write these values in 1, 2, 3. If you want to copy down the table, that's okay. But once again, this is only 2 points, and this will get you full credit. Question 27 is all conceptual. We don't actually have to do any algebra. We just have to know what each term means. So what we have here is the table below shows the height in feet of a hot air balloon, the number of minutes, t, the balloon is in the air. So this is just explaining what everything means. And now what we have is the function h of t can be used to model this data in the table. And this is the actual question. We have to explain the meaning of the slope in the context of the problem. Well, just know when you have a linear function, the slope as a concept is the rate of change. Okay, so the slope tells you the rate of change of your function, which tells you how fast it's going up or going down. And in this case, our slope is positive, which makes sense because the hot air balloon is rising. So the meaning of the slope is it tells us the rate of change of the height of the balloon in feet per minute. So once again, the $1 million phrase in your explanation is the word rate. The slope represents the rate of change of the function. So it's telling us how fast the balloon is rising. Now, the y-intercept If we have to explain what that means, the y-intercept is the fixed or the initial condition. So this is like the initial height of the balloon, if we read it in the context of the problem. All right, if this were an example of something with money, usually it'll be like, oh, a cell phone plan costs this much money per month, and that number at the end would be the startup cost, the fixed amount that you have to pay. But in a context of a hot air balloon, this would represent the initial height of the balloon at time 0. The first thing that comes to mind with question 28 is, I think, difference of two squares. So this formula is a must-have for the algebra regions. You have to know that a squared minus b squared factors to a plus b times a minus b, where the quick way to go through this is just to do the square root of the first term plus or minus the square root of the second term. So notice here, what I'm also thinking is that the square root of x to the fourth is equal to x squared, and the square root of 16 is equal to 4. So when I go to factor this here, the first thing I'm going to do is call this x squared plus 4 times x squared minus 4. Now, a little trap here is that this part, we're factoring completely, and we're factoring over the real numbers. This is not going to have any factors over the real numbers. Later on in advanced algebra, you learn about complex or imaginary numbers. But this one here is already factored completely. We can't break this down any further. But this one, x squared minus 4, we could do the difference of two squares formula again. So now we're going to leave the x squared plus 4 alone. But this one, we do x squared minus 4 factors to x plus 2 times x minus 2. And if we needed to check, we could always multiply this back out, and it would bring us to this. So factored completely, here's our expression. Question 29, we have Mike knows that these 2 points are on the graph of an exponential function g of x, and he wants to find another point on the graph of this function. And here's his process. First, he subtracts 6.5 from 17.5 to get 11.05. Then he adds that number to 17.55 to get 28.6. And then he states that this point is on g of x. So the question here is he correct? And we have to explain our reasoning. Now, right away, what I'm thinking is that what Mike just did is he used the process for finding points on a linear function. Because if we have a linear function, let's say I just draw something random like this, the rate of change of a linear function does not change. That means if we keep rising and running by the same amount, we're going to get from one point of a line to another point of a line. And we could do that process forever. But that's only for a linear function. If you were to try that on an exponential function, notice that for an exponential function here, whatever you rise and run to get from one point to the next, if you try to do that same amount, notice it's not going to put you on the exponential curve, because in the case of this type of exponential function, the rate of change increases. It goes up faster than it did previously. So he is not correct, and the reasoning is that an exponential function does not have a constant rate of change. So question 30, they're telling us to use completing the square to determine the vertex of this function here. And this is a quadratic function. And then we have to state the coordinates of the vertex. So what you need for this question is you have to know the vertex form of a quadratic equation, which is a times x minus h squared plus k. And just know the vertex in this formula is the point h comma k. So we need to turn this function f of x into this form. And then the next thing I think about when I'm looking for, or when I'm looking to complete the square, is I identify the b term of our quadratic equation. I cut it in half and square it. So here the b term is negative 14. So I want to take negative 14, cut it in half, and then square it. And then if I did negative 7 squared, that's 49. So this is a significant number that we need to use here. So then what I'm going to do is I'm going to take f of x, and I'm going to write the x squared minus 14x. But now this is the magic number that we need. We need 49. But notice I'm going to leave a little space here. And actually, let me leave even a little bit more space. So we have the minus 15. But what I want to do is I want to introduce plus 49 here. But I can't just add 49 to this and hope nobody notices. So what I'm going to do is I'm going to add 49, and then I'm going to immediately subtract 49 right after. And I think we could agree this is okay because 49 minus 49 is 0. So I really just added 0 in a really fancy way. And now how does this help us? Well, now this part, x squared minus 14x plus 49, is something that we could factor nicely. And this is going to be f of x equals, this factors to x minus 7 times x minus 7, which I could call x minus 7 squared. If we were to expand this, it would bring us right back to this step. And now this part, minus 49 minus 15, that's going to give us minus, and we're going to have 64 at the end like this. So now notice that our function f of x is in the vertex form here, so we could easily identify the vertex now. Just one thing to be careful with is that h has a minus sign in front here, so we have to take the opposite. So here, the vertex, we could just identify. Notice it's x minus 7, so that means h is equal to 7. That's the x coordinate of our vertex. And then we have plus k at the end, so our k value is minus 64. So that's going to be the vertex of this quadratic equation. Now, if we want to check our answer, this is very easy to check. We could just switch over to the calculator. So we go over to the y equals here, and now we're just going to type in that function. We have x squared, and we could even write it in the original form, or we could write it in the form that we made. Either way, it's not going to matter. So x squared minus 14x minus 15 like this, and we could write our answer under it just to make sure they match. But what I'm going to do is I'm going to go to the table, and we're claiming that the vertex is at 7, negative 64. And notice this is the turning point of our function. When x is 7, this is where we have the symmetry in the y value. So that's definitely our vertex. Question 31, we want to take this formula and we're going to solve it for f so that Josh could convert from Celsius to Fahrenheit. All right, so for this one here, what we're going to do is we're starting with this equation. And what makes these a little bit annoying to solve, this is called solving literal equations, is that no variables actually cancel out. We're just moving things from one place to another. So our goal here is to solve for f. So the first thing I would do is get rid of this 5 over 9. And the way you get rid of 5 over 9 is you can multiply both sides by the reciprocal 9 over 5. And notice now 5 over 5 cancels, and then 9 over 9 cancels. And that gives us 9/5 times c is equal to f minus 32. So now to solve for f, just add 32 to both sides. And this is going to tell us the equation for f. This tells us that f equals 9/5 times c plus 32. So here's our formula for Fahrenheit. Question 32, we're solving this equation algebraically for w. We're rounding to the nearest hundredth. So as soon as I see a quadratic equation like this, I just immediately think of the quadratic formula. So this is the $1 million formula to use here. And this one, I believe, is in the back of the test. So on the algebra Regents and all the Regents, they have some formulas that they give to you, and this is one of them. So then what I would do here is, before we actually identify A, B, and C, I would take this, since everything on the left side is divisible by 4, I would just divide everything on the left and right side by 4, just so that the numbers that we plug in are actually easier. Even though the calculator is going to do the work for us, we're going to have w squared plus 3w, and then we have minus 11 equals 0. Now we could try to factor this here, but the only factors of negative 11 would be 11 and negative 1, or negative 11 and 1, which wouldn't add up to 3, which tells me right away when they're telling us to round to the nearest hundredth that we're going to have an irrational, two irrational roots here. So now we go forward with this, and I could say, all right, a equals 1, b equals 3, and c equals negative 11. And now we're going to say that w equals, and we have negative b plus or minus the square root of, and we have b squared, and let's just make this a little bit darker here. So b squared, we have 3 squared minus 4 times a times c, and we're dividing by 2 times a, which a is equal to 1. Now just be careful of this trailing part here, because I always take my time at this last piece just to make sure if there's any sign change that I don't miss it. So here what we have is w equals negative 3 plus or minus, and now this is going to give us 9 minus, and we have 4 times negative 11, which is plus 44. So we're going to have 9 plus 44 here, which is going to give us square root of 53 under the radical, and we're dividing by 2 times 1. So the rest here is calculator work. We're going to ask the calculator, what is negative 3 plus root 53 over 2? And then we're going to ask the calculator, what is negative 3 minus root 53 divided by 2? So we'll go back to the main screen here, and we're writing in the fractions. We have alpha y equals enter, and we have negative 3 plus square root of 53, and we're dividing by 2. So this is one of the roots. And then the next root, if I want to save a little time here, I just hit enter on that previous expression, and I scroll up to the plus sign and just make this a minus here. So we'll just switch that to minus. And here's my two answers. We have 2.14 and negative 5.14. So we'll just write our two answers in here. This first one worked out to 2.14. And then the second one here, when we're subtracting root 53, gave us negative 5.14. So here are the two values for W for this question here. Question 33, we got this table here for number of jumping jacks and heart rate for Joey. And the first thing we need to do is state the linear regression equation that estimates the heart rate per number of jumping jacks. So we'll just switch over to the calculator view and we'll go to stats and we're going to edit the table. So we have to enter both columns. So on the first column, we had 0, and then there was 10, and the next was 15, 20, and then the last entry was 30. So now we're just going to write the next column immediately next to it. And we had 68, so 68 here, and then we had 84, and then it was 104, we had 100, and then the last entry here was 120. Now, for this part here, I want to say hit second 0. And what you want to do is you want to scroll down to D, but to save time, you could press Alpha X. So let's just press that twice, and that'll help you scroll a little bit faster. You're going to scroll to diagnostic on and make sure that this is turned on, because that way what we could do is now we could go to stats. We're going to calculate the linear regression as number 4. So we're calculating the linear regression for both columns, L1 and L2, because we need an X and a Y column to write the equation of a line. And now notice, instead of mx plus b, they use ax plus b, but our line is going to be y equals 1.72x plus 69.4. What we also get out of this information is the r value, which we're going to need for the next part. So now we'll just write out our equation. We have y equals, the slope was 1.72, so we have 1.72 times x plus the y-intercept was 69.4. So here's our linear regression equation. So now we want the correlation coefficient, and we're rounding to the nearest hundredth. So that's the r value here. And if we're rounding that to the nearest hundredth, we're going to look to the right of the hundredths place is a 7. So we're going to round this to r equals 0.97. So we have 0.97. For the last part, I always think about this about correlation coefficients, that they have to be between -1 and 1. But any correlation coefficient that's close to 1 or -1 is very strong. So this would be a strong positive correlation, and -1 is a strong negative correlation. So the fact that we're really close here to, and let's just get rid of that stray mark, we're really close to +1 tells us we have a strong correlation coefficient, which means that there's a strong correlation between the number of jumping jacks and heart rate. Question 34 is very wordy, but we're told Hannah goes to the store and she spent $16 on school supplies. And here's where we start defining variables. She bought 4 more pencils than pens and 2 fewer erasers than pens. So right away for this, I'm thinking, all right, I'm going to let pens be modeled by X. And then I start doing everything else. So then pencils, if we reread this again, for pencils, she bought 4 more pencils than pens. So that means pencils, if there's 4 more pencils than pens, we could call this X plus 4. And then Hannah bought 2 fewer erasers than pens. So erasers, we could model this with X minus 2, because once again, she bought 2 fewer erasers. So we're doing X minus 2 for this. And now we're told the cost here. So pens cost $1.25, pencils cost this much, and erasers cost this much. So, oh, and they tell us X represents the number of pens. So that took away this part for us. We need to write an equation in terms of X that could be used to find out how many of each item she bought. So the key with these is you put the rate or the cost of each item in front of the variable. So if pens cost $1.25 each, we could say 1.25 times the number of pens is X. And then we're going to have plus pencils are 55 cents. So we could put 0.55 times the number of pencils is X plus 4. And then what we have next is erasers are 75 cents. So this is plus 0.75 times X minus 2. And then we just set this all equal to the total bill, which was $16. So this is our equation here for the first part. So now we have to solve this equation because we want to find out how many pens Hannah bought. So now let's solve this out. We have 1.25 times X. And here we're going to distribute the 0.55. So we have 0.55 times X is going to give us, we have 0.55 times X plus, and now if we multiply this by 4, if I double that in my head, that's 110, and if I double it again, that's 220, but we're going to have a decimal there, so this is 2.20 like this. Plus, and now we distribute the 0.75, and we'll have 0.75 times x, and then when we multiply by minus 2, we're going to have minus 1.5, and this is equal to 16. So now from this part, we just combine the like terms. So we have this, plus this, plus this. So just going through this part, this is going to give us, if we add that, that's going to give us 1.8. And then if we do 1.8 plus this, plus 0.75, that's going to give us, we're going to have 2.55 times x. So that's combining the x terms here. And now 2.20 minus 1. I think of this as 220 minus 150. That would give us 0.70. So we're going to have plus 0.70, and this is equal to 16. So now we just finished the algebra. We're going to subtract 0.70 on both sides. And from this step here, we subtract these. We're going to have 2.55 times x equals, and then 16 minus 0.70 is 15.30. And then just divide both sides by 2.55. And that's going to tell us what x is. So we get to this step here, and if we divide those, x is going to equal 6. So now we just have to determine how many pens did Hannah buy. Hannah bought 6 pens. So we'll just write out our final answer here. And this is the end of question 34. For question 35, we have to graph this system of inequalities on the set of axes below. So the main skill we need for this question is we have to be able to graph lines when they're in the form y equals mx plus b. And just know m represents the slope and b represents the y-intercept. So that first line, well, inequality y less than or equal to this, I right away notice the y-intercept is 5, which means if I go to the y-axis and I go to 1, 2, 3, 4, 5, I already have a point on this line. And now the slope is negative 3 over 4. So what that tells me is that we're going to rise, or we're going to go down 3 units, and we're going to go to the right 4 units. So this tells me how to get from one point to the next. So I'm going down 1, 2, 3, and I'm going over 1, 2, 3, 4. And I do this a few times. I'm going to go down 3 over 4 again. And when I go down 1, 2, 3, and over 4 like this, I can already see here visually that this is forming a straight line. And now if I want to do things in reverse, I'm going to go up 3 to the left 4. So I'm going to go up 1, 2, 3 to the left 1, 2, 3, 4. And now this gives me the other point. So then what I do from here, because this is less than or equal to, all these points here are solid, and I'm going to connect them with a solid line like this. So this is an important step, that we connect it with a solid line. And because this is less than or equal to, I'm going to shade everything under the line like this. So I'm going up to the line like this, and I'm just going to shade everything under just to highlight what the solution set is here. So here's our solution set. Now the problem with the second line here is that for this line, it's not in the form y equals mx plus b, or I should say y greater than or less than mx plus b. So what I would do first here is I would subtract 3x on both sides, and that's going to bring us to this step. We're going to have negative 2y is greater than, and let's just make this a little bit darker. So we have negative 2y is greater than negative 3x plus 4. And then from here, to solve for y, I'm dividing both sides by negative 2. And because the right side has more than one term, I'm dividing everything by negative 2. And now this cancels out, but remember, a very important detail is that when you divide or multiply both sides of an inequality by negative, the sign flips. So now this is going to be y is less than, a negative over a negative goes positive, so I have y is less than 3 halves x, and then 4 over negative 2 gives us minus 2. So this is the new inequality that I want to graph here, and it's in that form mx plus b. So notice here what we have is we have a y-intercept of negative 2, and this time I'm doing open circles and a dotted line because it's strictly less than. There's no equal to underneath. So now I have my starting point, that's our y-intercept, and now the rise over run, we're going up 3 to the right 2. So I'm going up 1, 2, 3, and I'm going over 2 like this. So that would be the next point. Then I'm going up 1, 2, 3, and over 2. And once again, you know you're doing this right when you could see that these points or open circles are forming a straight line. And if I do this one more time, I'm going up 1, 2, 3, and then over 2, which would bring us right around here anyway, and it's colliding with our work. So now if I want to go backwards, I'm going down 3 to the left 2, and this should be sufficient here for plotting the next inequality like this. So I'm doing this one with a dotted line because once again, it's strictly less than. And now I'm going to shade everything under this line. Oh yeah, and of course it was continuing here like this, so I could put my arrow at this end or the other end. But now I'm shading everything under this line as well. So here is the next solution set here. Now, the final part of this question is asking, is 6, 3 a solution to the system? Well, what I would do is I would plot that point. I'm going over 1, 2, 3, and let's make sure I'm counting this carefully. So I'm going over 1, 2, 3, 4, 5, 6, and I'm going up 1, 2, 3 like this. So this is the point 6, 3 is over here. But notice the solution set is the part where both inequalities collide. So it's where the purple shaded region meets the blue, which is in this section over here. So notice 6, 3 does not lie in the solution set. So 6, 3 is not a solution to the system of inequalities. Question 36, we have a ball is projected in the air from the surface of a platform, and they give us an equation to model the path of a ball here. And what I think about for questions like this is, first off, they want us to find the height of the platform in feet. So this quadratic equation, if we treat it as a real world scenario, is going to model the path of the ball from the moment it's launched. So it's going to take on this kind of shape here if we were to type this in the calculator. And we're only to look at when t is greater than or equal to 0, because we're starting at time 0 and then going in the positive direction. So when I'm looking for the height of the platform, I'm immediately drawn to this point here because the ball is being launched from the platform. So the height of the platform is going to be the y-intercept here. So if you have to state the height of the platform in feet, I could just say here f of 0, and the function value at 0, if I plugged in 0, it would leave us with just 112. So this tells us the height of the platform in feet is going to be 112 feet. So it helps to be able to visualize these problems when you're doing them, and I don't even need to type this into a calculator to know what it's going to look like because it's a ball being launched. So for the next part, we want to find the coordinates of the vertex, and we need to explain what it means in the context of the problem. Well, if you think about it, if a ball is being launched, the vertex, the turning point, represents the maximum height that the ball reaches. So now if we want to find the vertex here, there's a few ways we could do it, but what I think about for vertex is I think of this formula, x equals negative b over 2 times a, where a and b are the coefficients of the quadratic equation. So here, what we're going to do is we're going to say t equals, and we're going to have negative b, which would be negative 96, over 2 times the a value is negative 16. And if we work this out here, negative 96 over negative 16 goes positive. 96 divided by 16 is equal to 6. So I'm going to have 6 over 2. And then when I do 6 divided by 2, that's going to equal 3. So once again, when I simplify this, this is going to equal 6, and then 6 over 2 simplifies to 3. So then what we're going to find here is what is the y value at t equals 3. So we could go over to the y equals here and just type this in. So what we have is negative 16, and we're going to use x squared here because that's the mode the calculator's in right now. And we have plus 96x and then plus 112. Now, when we write our answer later, we could talk about things in terms of t, but the calculator won't mind if we use x. So when we go to graph this here, this really doesn't show us anything that we need to. And the key to really getting good numbers for this question is I look at the table here and I see, okay, from x equals 0, our y-intercept is 112. And I look for the biggest value in the table is 256. So far what I see is I might want to go out to 8, even though the ball hits the ground at t equals 7, because that's when we go to time when we go to y equals 0. I would want to go up to about maybe 270 so I get a good picture of what's going on. So we're going out to 270, and I could start this at 0, or maybe I'll just go to -1 so I could see a little bit to the left here. And then we're going to stop at t equals 8 because at t equals 7 the ball hits the ground. So you can see like this gives us a better idea of what's going on. If this annoys you because the ball is being launched at time 0, what you could do is you could just swap this out with a 0 here, and then it's going to give you a more complete picture of what's going on. But now we said the vertex occurs at t equals 3. So what I could do is go to the table, and at t equals 3, the height is going to be 256. So I could say here f of 3 equals 256. So the vertex, we'll just state the coordinates. The vertex is 3 comma 256. And what does this represent in the context of the problem? That's the maximum height the ball reaches. Now, I like to include units in my answer because you never know how strict the person grading your paper is, but this would capture the meaning of the vertex in the context of the problem. For the last part of this question, we need to state the entire interval over which the ball's height is decreasing. So what I'm thinking about right away is I think back in terms of the graph, And when we think about the graph here of the quadratic that models this scenario, the ball's height is decreasing right after it reaches its maximum height. It begins its descent and it hits the ground. So what we're looking for are the two times. One where the ball makes its turning point, and two when the ball hits the ground. And if we remember from the graph, it made its turning point at the vertex at t equals 3, and then it hit the ground at t equals 7 because we said before f of 7, according to the table, was equal to 0. So the entire interval, we could say the ball's height is decreasing from t equals 3 to t equals 7 seconds. If we want to write the interval out a little bit more formally here, what we could say here is that t is between 3 and 7 like this. All right, moving on to part 4. This is the final boss, and it's worth 6 points. So we have a local garden shop, and we have the price of plants, and this includes the sales tax. So we have the cost of 4 large plants and 8 medium plants is $40. And then we're told the cost of 5 large plants and 2 medium plants is this much. And L is going to model large plants, M is going to model medium plants, and this is the first task. Write a system of equations that models this situation. So here, L represents large plants, so I'm going to have 4, and I'm going to use a script L so it doesn't look like a 1. So we have 4 times L plus 8 times M is equal to 40. So here's one equation, but then we use the next sentence. 5 large plants would be 5 times L plus 2 medium plants is, which is going to tell us equals $28. So here's our system of equations. So the second part, we want to verify if the cost of one large plant could be $5.50 and one medium plant if it could be $2.25. And we have to justify our answer. So what we have to do is we have to plug in L and M for these values, and it has to work for both equations. But watch what happens if we plug it into the second equation. If we plug in L is $5.50, so we have 5 times $5.50 plus 2 times M is 2.25. If you were to plug this in and try to verify this here, this is going to work out to 32 when it should be equal to 28. So this equals 32, which is not equal to 28. So this tells us these could not represent the cost of a large and medium plant. So now for the last part of this, we're going to determine algebraically both the cost of a large plant and a medium plant. So I want to solve this system by elimination. And what we could do, notice the top, everything is divisible by 4. But when you're doing elimination, you want to have matching coefficients, but you want them to be opposite. So this top equation, I would multiply by -1/4, which is the same thing as dividing by -4. And watch what that does. This is going to give us -L, because I'm doing 4 divided by -4 is -1. So I got -1L. And then if I do 8 divided by -4, that's -2, and that's in front of M, equals, and then 40 divided by -4 is -10. So that brings us here, and then we just copy the second line down. We have 5L plus 2M equals 28. So then what we could do with this here is we could add these two together, and these terms are going to cancel out, and then 5 plus -1 gives us 4, and we have 4 times L equals 28 minus 10 works out to 18. So now we just divide both sides by 4, and this is going to give us the value of L. We're going to have L equals, and then 4 goes into 18 4 times with the remainder of 2, and 2/4 is equal to 50. So this tells us L equals 4.5. Now what we're going to do next is we're going to take L equals 4.50, and we could plug it into any of these equations. But I don't know, let's just say I just pick a random one here. Let's say I plug it into this equation here. So I would have 4 times 4.50 plus 8 times M is equal to 40. And then from here, we just multiply this out. And 4 times 4.5, well, 4.5 times 2 is 9. And if I double it again, that's 18. So I have 18 plus 8 times M equals 40. And now I would just subtract 18 on both sides. And this is going to give us 8M equals, and when we subtract those two, we're going to get 22. And we divide by 8. This tells us here that the value of M, just do the division, 22 divided by 8, well, 8 goes into 22 twice with 6 left over, and 6 over 8 is 0.75. So we're going to have 2.75. So now we can just write out our answer formally.